Let's look at another problem. Remember that the first thing I want to do is confirm standard form and at the same time confirm if I'm missing any terms. So as I go along, I see 4 is my degree followed by a 3. Ooh, I don't have an x squared, so I'm going to have to put one of those placeholder zeros in. Then I have an x to the first and finally a constant. In my divisor, I have a squared, a first power, and a constant, so that part's good. So as I write my long division problem, remembering to leave myself some space above for my quotient, I'm going to say x squared plus 3x plus 2, but then as I write my dividend, I need to say 2x to the fourth plus 3x to the third plus, and that's where I insert a 0x squared, and then continue, plus 5x minus 1. If you don't have a separate color of pen, I suggest that maybe you circle this term to really bring your attention to it, something to make sure that you see that there's an extra term there because we have to have everything, 4, 3, 2, 1, 0. Okay, so now same process as before. I ask myself how many times will x squared go into 2x to the fourth? And writing that off to the side again if you want to, 2x to the fourth divided by x squared is going to give me 2x squared. And so that is the first term of my quotient. Remember to write it above the matching terms, the like terms. So I'm going to write it above that 0x squared that I stuck in there as a placeholder. This is the reason for that. 2x squared multiplied by every one of these terms. So I'm going to get a 2x to the fourth. 2 and 3 is 6x to the third, and then 2 and 2 is a plus 4x squared. And I'm ready to subtract again, just like I did in the first problem. And just like in the first problem, these are going to go to 0, 2x to the fourth minus 2x to the fourth, 3x to the third minus 6x to the third. Well, that's going to give me a negative 3x to the third. And then finally, 0 minus 4 is going to give me a minus 4x squared. I bring down the 5x and I repeat the process. From here, why don't you guys pause the video and see if you can do this on your own to finish up the problem, write it with remainder over divisor, and then come back here to see how you did. All right, so we want to see how many times that negative 3x to the third can be divided by x squared. So doing the math off to the side, I get negative 3x, and I will add that up here, negative 3x minus 3x. Now I take that minus 3x and multiply by each term. I get a negative 3x to the third minus 9x squared minus 6x, and I'm ready to subtract everything. These two terms cancel. Negative 4x squared minus a negative 9x squared is a positive, so 4 plus 9 is 5. I have 5 minus a negative 6, minus a negative, again, gives me a positive, so 11x, bring down the 1, and then repeat everything one final time. How many times will x squared divide into 5x squared? Doing that math, it's 5. So I add a plus 5 up here, and I take this plus 5 and multiply it by every term. Once I do that, I can subtract everything, and I'm going to get a negative 4x minus 11 for my remainder. And I write my final answer as my quotient here, and then plus remainder over divisor. I want you to get some more practice before we move on to our next type of division, so please go ahead and try problem number 3 on your own. Remember to check for standard form and any missing terms before writing your long division problem. All right, now that you've practiced, let's see how you do on problem number 3. So the first thing that I notice is that everything is in order and there are no terms missing. 3, 2, 1, 0. 2, 1, 0. So I can just write everything as I see it into long division, and I ask myself, how many times will x squared go into x cubed? I did that off to the side and I came up with x. 3 minus 2 gives me a exponent of 1, and remember to write the x aligned with the 10x. Remember that everything wants to be aligned. Taking x and multiplying by every single term in the divisor, I get x to the third plus 4x squared minus 2x, and I'm ready to subtract all of those terms. This first one goes to 0 because x cubed minus x cubed is 0. 7 minus 4 gives me a 3x squared. 10 minus a negative 2 is a plus 12, and I'm ready to bring down the negative 6. Once I do that, I start the process over again. I ask myself, how many times will x squared go into 3x squared? Doing the math over here, off to the side, kind of as scratch work, I get 3, and I add 3 up here in my quotient above the negative 6. Remember that this should all be aligned. Multiplying everything by 3, I get 3x squared, 12x minus 6, and I want to subtract everything. Notice what happens here. We have a remainder of 0 because everything canceled, all 3 terms. So with a remainder of 0, my answer is simply my quotient, x plus 3.